Hello, my name is Ellie Johnson, and this is my Physics Lab 2 online charges. So, in this lab, it is basically an extension upon Lab 1. So, in Lab 1, we created a charged Scotch tape and then observed the behavior of this tape. And then, as you see in the diagram to the left, we created a suspended U tape. In Lab 1, we're going to use the same amount of charge as in Lab 2. However, in Lab 1, we treated the tape as a point charge with all of the charge in the center of the tape and all of the calculations only taking into account the center of the tape, and we assumed that both tapes were equally charged across the whole tape. However, in Lab 2, we're going to calculate this charge differently. So we're going to do this by using a line charge rather than just a single point charge. So a line charge is basically when you're going to divide the charged objects into a collection of point charges, as you see in the diagram below. I have multiple different point charges across this piece of tape, and those are all going to be different calculations that are going to be added together and find the entire charge. So the point is basically to calculate a more accurate measurement with more information on the charges of the tapes. So with my Lab 1 data, a lot of the measurements are going to stay the same, and these are the original calculations. And at the bottom, you see a diagram where I'm showing how I'm representing the charges with those single points right there. However, in Lab 2, the diagram has changed. I've shown the multiple points that we're going to use to calculate that charge. So the concepts we're going to use in Lab 2 are Coulomb's law, which we also use in Lab 1, which is basically just how you're going to calculate this force. And then we're going to use the concept of polarization again, which is basically when a neutral object is going to become a temporary dipole when it comes into contact with a charged object, and then it will become attracted to this charged object. We're also going to use the concept of superposition. So basically, this is when every single charge within a space, so the space of the tape, is going to create its own electric field, which are all independent of each other. And then the total electric field is going to be a sum of all of these individual fields. And the way that we're going to apply the superposition concept to Lab 2 is that we're going to divide the charge evenly into point charges. So we already have the charge, and we're just going to divide that up. I used 10 different point charges, and then we're going to compute the electric field of each individual point and add them together. So this is a couple parts of my code. As you can see on the left, I'm showing how I'm going to iterate through each charge element in the tape. So I'm going to iterate through each of these elements and then calculate their electric field, and then at the end I'm going to add them all together to get the total charge, which is shown on the left. And then at the top you're going to see both of my line charges, which I plug into that equation. And also on the right you can see my diagram that I calculated, which shows all of the individual electric fields of each point charge that I calculated and what direction they're going in. Finally, some questions, basically comparing the different charges that I got for the point charge and the line charge. So the point charge is going to be smaller than that of the line charge, and then what assumptions did I make? So we did not ignore air resistance on a moving object because it's not moving. And we did not treat the long tape as if it was a point charge. We actually treated it as if it was a line charge. And finally, what if we had modeled it such as it was a single point charge and compare those values to this value? So basically, the point charge is going to be much smaller than the line charge because the mass is going to be concentrated with the point charge. However, it only is going to account for the y direction. However, in the line charge method, we have all the individual point charges spread in the x direction, so we're going to take into account that the amount of mass spread in that direction and the charges spread in the x direction as well. And these differ because of the differences in the charge distribution, and the line charge is going to be a lot closer to the real life value because in real life the charge is going to be spread across and not concentrated in one spot. Thank you for listening. That is the end of my lab. basically, just in conclusion, we use superposition to break up this charge into multiple charges, and the point of this lab was basically just to reflect a more accurate way to calculate this charge, because in real life we have charge spread across a surface rather than concentrated in one spot. Thank you.